Well, good evening and welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Very kind of you to be here. We hope you enjoy tonight's show. I have some of the usual suspects with us tonight. We've got Daz all the way over there in deepest. Well, we don't like to reveal exactly where he is because
No. We don't want to give away my location.
The electric fences have failed at the moment. And, he might be able to get out. So
looks like you're under a booster. That's not a good idea, Daz.
Oh no, that's right.
Just to keep me back warm. I got back problems. So yeah,
yeah, he's got 33 raptors behind him.
Hey.
Yeah. We have Michael. How are you, Michael?
I'm fine, thank you.
In the blackest of the black country.
Yes.
Yeah. So you okay, Michael?
Yes, thank you. Yes, fine.
Good to see you.
Yeah.
As always, we've got Roger. How are you, Roger?
Oh, fine. Thank you very much.
Good.
All's well down in Somerset.
Yeah. And from the US, we have Lou. How are you, Lou?
Oh, doing well, thanks. Finding a few clear skies so I can play with my Sea Star. Having fun.
Oh, you've got a Sea Star now, have you?
Yeah. Well, the university purchased it. I've got it.
Oh, right.
Not giving it back.
No, perhaps not.
Well, good luck with that. We've had a week of rain and thunderstorms. So the rain has turned up eventually. So our drought situation is not as precarious as it was. But anyway, we got more storms forecast for the rest of the week, I think. So haven't had a chance to get out and even look at any stars because it's been mainly cloudy and wet at night. But never mind, we've got our glorious summer just around the corner. So there we are. Anyway, as I said, thank you for being here. If this is your first time watching Space Oddities, what's taken you so long? Because we've been here for coming up to 2 years. In fact, we hit our 2-year anniversary at Space Oddities next week.
Ooh,
party. I don't know whether you realise that. We celebrate our second anniversary at Space Oddities next week. So perhaps next week we'll do a bit of a special and look back on some of our highlights, which won't take very long.
That won't take long.
We might show you the lowlights instead.
Let's hope it is.
Yeah. And I was thinking maybe we could do a behind the scenes look, but I don't think our viewers might want to. No, it's probably
No.
You don't want to see what's below the waist here.
Preserve the mystery.
No, we definitely don't want to see that, Daz. We want to keep our viewers, not send them away screaming. All right, so what have we got for you this evening? Well, as you may know, last week was a bit of a bumper week because of the enormous geomagnetic storm that we had and the aurora that so many people around the world saw. And Daz is going to update us on what's going on in the sun a bit later today. And I will, of course, bring you the news, as always. We've got news of the first engine test of a German rocket at Saxevord, the Shetland spaceport, all pushing ahead for a launch, I think, in September, isn't it meant to be, Michael?
Yeah, they're pushing on really fast.
Yeah, we've got the first launch of a rocket from British soil in September at the new spaceport.
But it is a German rocket.
It's a German rocket, yes, of course, but it is from British soil.
Yes.
Of course, the Virgin rocket would have been the first had it not been a failure. So we'll look forward to that. We'll bring you more news of that nearer the time. So let's just do a bit of the normal housekeeping stuff. Don't forget that the Space Oddities merchandise is available. We have our new spring and summer collection from Space Oddities, the T-shirts, of course. These are £20, including UK postage and packing. The wonderful new design that we've come up with, and we hope you enjoy that. We've also got the Space Oddities hoodies. These are £40, including UK postage and packing. And we've got the older designs, last season's collection from Space Oddities, which is the old design. That one is available in 10 colours. The new one is only available in black. And the old hoodies as well. Again, £20 and £40 respectively. And then, of course, if you want to have a look at the whole of our merchandise range, you can scan the code here. And it should have just popped up in the chat as well. And there you are. That's our merchandise. We would like to thank you for your ongoing support of Space Oddities by buying us coffees and buying super chats and all the other ways you can support us. But if you would like to buy us a coffee, then you can scan the code here and you will be taken to a place where you can buy us a coffee and help to keep the channel running, which obviously, as we're just coming up to our second birthday, we would like to see a third birthday. So every little bit helps us keep the show on the road. So that's that bit over with. And it's been quite a busy week with space exploration one way or another. The first crewed launch of the Boeing Starliner, which we'll probably be talking about a bit later, has been pushed back again and again, and it's now scheduled for no earlier than the 26th of May. If we can, we'll bring you that launch live. And the Starship this week underwent a full stack wet dress rehearsal to prepare it for its fourth attempt to get into orbit, and more importantly this time come back to Earth safely. And we hope to bring you that launch live, because this is a really crucial launch for SpaceX. If they don't get the next one right, I think a lot of questions are going to be asked about the future of the Starship. So we'll bring you all the latest about that. Apart from that, what we'll do now is go straight over to the man with the most, or whatever he has. That's Roger, of course, who'll do our usual look at the night sky. And this week's gallery, we do want to thank you all, as always, for sending in your wonderful images to the weekly viewers gallery. We've had a lot of Aurora images. We showed some last week. I believe we got more this week, Roger.
We do have a few, but we'll get to that at the relevant point in the presentation.
Okay.
Oh.
So if you would like... Yes. He's forgotten to take his meds again, hasn't he?
He's been on the cider. He's getting all obstropolous.
Yes, absolutely. So if you would like to include your image in our weekly viewers gallery, then please attach them to an email. One image per email, please. Mail it to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And if you could include the word gallery in the title, that will automatically filter it out. So, yeah, absolutely. So, yes, if you could include the word gallery in your title of the email, that would be fantastic. And without more ado, let's go and see what Roger's got for us this week.
Apart from the handbags.
Apart from the handbags.
I don't know. So here we're getting through to a full moon later on this week. This was what was visible last night. And today's solar view today, we've still got quite a few, all gradually spread out through the southern hemisphere, and some more details closed up on the right. But we're obviously seeing what 3664 might present itself to us on its return, shall we say? Should it be in the same state it was as it left around the western limb? So
we have some news on that, Rog.
Yeah, all right. Spoiler alert. Okay, so we've got the full moon in the latter part of the week, and that's not going to do us any favours with what's going on. But we've got nothing planet-wise up in the night sky at the moment. And from my location in Somerset, from Thursday, there will be no more astronomical darkness. So there we go.
Oh, dear.
Never mind. But we do have the galaxy constellations of Leo and Virgo in the southern hemisphere, and this is at 10 o'clock, but at 11 o'clock we'll be getting the third of the summer triangle stars, Altair, rising in the east. So summer is on its way. But there we go. This is just to give you a position of where the planets are at the moment. Obviously, you won't really be able to see them at all properly. Maybe Venus, but it's very close to the sun, so it's not really advisable trying to look for that even. But most of the planets are coming up just before sunrise, so we've still got the latter part of the year to see those, but not at the moment. But there are some conjunctions through the week with some of the planets, so that might have been an interest. We've still got Comet Obers going through Auriga, which may be of interest to some comet chasers. It is still brightening up. It's going from 6.7 to 5.4, and it's in Auriga. And if you look at the chart down the bottom there, it's saying it's circumpolar. So that might give us. So it will be brightening up even more to help possibly be able to be seen. But obviously, with the lack of astronomical darkness, it might be a bit of a challenge. But obviously, those with some binoculars or telescopes might be able to get something. And then we've also got Schunnerson Atlas, which is still travelling slowly through Virgo, although that is still brightening up. It's supposed to be getting its brightest in the autumn, but it's starting to develop more of a tail, so it's becoming a bit more of an interest. But from what I've got this week, there's more information on one of the other planets in the system that we were talking about last week. This is 107b, and it's managed to, during the time that it was in front of the star, they did manage to get quite a lot of information on its atmosphere. So
what have we got there? We've got CO2, ammonia, methane, sulfur dioxide. Interesting.
Yeah, and a bit of water. So obviously and they're all coded from what instruments detected those particles in the atmosphere. So it's turning out to be a bit of an interesting one there.
Lou, have you got any comments about this? Can you enlighten us about anything interesting to look out for?
I think this is a super Earth. Am I wrong in terms of mass?
It's of a similar mass, yes.
Okay.
From what I can see here.
So we keep looking for evidence of habitability, right? We're not seeing life, we're looking for evidence of habitability. And when we find these things, we tend to say, oh, there's the best chance for life. But if you go very deep into the oceans and you see the incredibly bizarre diversity of life there, and you and up here on the crust, you see the diversity of life with the extremophiles. It really gives me a little pause, I should say, to maybe we're being too restrictive as we look for these things: carbon dioxide, water, methane, that kind of thing. I said methane, not methane. Just pointing that out.
Well then, yeah, because I noticed there's no oxygen there either, so except it's in the water.
Now, free oxygen, diatomic oxygen, would most likely be seen in the ultraviolet because it has a zero dipole moment. So these gases here are somewhat asymmetrical, and so we see their rotational vibrational lines in the infrared. I think that's the case.
Right, and the sulfur dioxide, I mean, that could come from volcanic processes, presumably.
Or sodic pop cans, either.
Yeah, they could be opening lots of bottles.
Yeah.
But because isn't oxygen a sign? If you do find oxygen in an atmosphere, it's a sign of some sort of possible life, because it's what can you say? It's sort of recycling. If you've got life, then it will recycle, so it will be present in the atmosphere for a lot longer, or permanently. Whereas if there wasn't any life, it would actually dissipate. Am I correct with that? It would join with other things and wouldn't be recycled or anything like that. If you know what I mean. I'm trying to mess with my words up, I think. But Oh, I did read some.
Perhaps there's a different type of penguin in the atmosphere there.
That could be it. That's
Rockhopper.
That's almost certainly it. Yeah, we haven't heard anything about the Venetian penguins recently, have we? It's gone a bit quiet.
No.
Yeah.
Anyway,
okay. Moving on.
Now we get on to the oddities gallery and what some amazing images we've got put in for this week. And we have got a few from Graham of the Aurora, and these are the ones that he's taken, not his son this time. So these have all been done with his phone. So
wow,
all the good for him. And
lovely.
Got some rays there as well.
Yeah.
Yeah, and of course this shows. Sorry.
Yeah.
No, I was just going to say it shows how big it was because you can actually see it, and you're looking through streetlights.
Yeah, absolutely.
I'm reminded that there's a Facebook group called I think it's called Cell Phone Astronomy or Cell Phone Astrophotography for people who are interested in using their cell phones within a community.
Okay. And his third one was there. Look at those.
Oh, he's got blues as well.
Blues, yeah.
Lovely jubbly.
Yeah, amazing.
I
guess that is Castor and Pollux there by the looks of it.
Looks like it, yeah.
Yeah.
Very good. And we've got some more Milky Way images. And here we go. This is what he calls Slatehenge, near the quarry where he is. Look at that.
Oh, that's
wow.
That's a wow.
Where'd it go?
Excuse me.
I
haven't finished my...
what happened there? No idea. Hang on one second. We'll put that back.
Oh, how rude. How rude.
Sorry about that. There you go.
That's lovely.
Lovely. Very good.
That is beautiful.
Yeah, that's very nice.
That is nice.
And the very regular Jerry with the Needle Galaxy in Coma Berenices.
Oh,
well, that's nice.
That's good. Lovely definition there, Jerry.
Very good.
Beautiful.
With another one swirling away in the background.
Yeah. That's NGC 5705 in the background.
Is it? Oh, all right then.
No, I just said that. I have no idea.
You shouldn't have said that. You would have been convinced.
Yeah.
Isn't it just amazing that galaxies like that appear edge-on to us, and it's pure coincidence that they appear edge-on to us?
Yeah, absolutely. And the dust lanes in that very well defined there, Jerry. Beautiful.
Yep. Very well done.
Well done.
Okay. And one from Sonia on her 10-inch Dobsonian.
Oh,
lovely.
That's lovely.
Pick that out. Okay.
That's lovely, Sonia.
Very good.
Beautiful.
Very nice. Well done. And last but not least, moi.
Who's that?
Oh yeah.
Moi.
Who's that?
Okay. This is I, Leclerc. This is just a this is a stacked image that was just done in SharkCap, one of their new tools that they do, a live stacking feature, and I just used this area to get some details, and it's come out quite well with Aristarchus there, and the Schroeter's Valley came out very clear on the low angle of the lighting, getting that quite well defined.
Yeah, because the bright crater looks though it's got a lake at the bottom. It's got a blue tint.
I know. It's always... I know. It's probably just a photographic anomaly.
Yeah, it's an anomaly. It's just but it's got a blue tint.
Sinus Iridium is looking quite nice.
Yeah.
Okay.
That's beautiful.
Okay. Right. Okay. Now you can switch me off.
Don't tempt me.
Okay.
So there we are. So thank you everybody who's sent in their images. Some lovely, aurora images there, and that's it. So don't forget, just one more time, if you'd like to include your image in the gallery, then please do send it in to spaceodditieslive@gmail.com. And we're very grateful for all your submissions, because, as we always say, we absolutely adore looking at your images, and the quality of them is never less than excellent. So I don't think we've ever had one image in that has been we've said, God, look at that, that's rubbish, isn't it? They're consistently fantastic quality. So thank you very much for that indeed.
Oh yeah, we'll let anything in. That's why we let Rod show in.
Well, if you think about it, we don't actually have a vetting process, because we never need to vet them.
Exactly. No, we don't. And there's standard.
I could just put all of mine in, and that's it.
Yeah.
You are the weakest link.
Taxi for Roger. So there we are. All right then, let's move on. Let's move on to the news, because there have been things in the news this week, believe it or not. So we will just have a look at this together. So just let me sort myself out here. Okay, so the first thing in the news. Before we start, let me pose a question to the viewers. What is the reddest object in the solar system? So if you can puzzle that out. If you know, or you have an idea, put that in the chat. What is the reddest object in the solar system? And let's see if we have any suggestions. And the eternal question of how did supermassive black holes form so big, so massive, so early in the history of the universe has raised its head again, because scientists have discovered the earliest ongoing merger of two supermassive black holes in the early universe, and this is the earliest ever discovered. And here it is. And this is quite stunning when you think about it. The earliest black hole merger in the universe is designated ZS7, recently discovered. It was happening just, in inverted commas, of course, 740 million years after the Big Bang. So you already have these enormous monsters, and these two are obviously in the center of nascent galaxies. They are merging. They haven't merged yet, and it will take maybe a few thousand, maybe a few million years, or it did take after that. You have to think this all happened a very long time ago. But this is the earliest black hole merger happening ever found. And each of those black holes has around 50 million times the mass of the sun, it is believed. And no surprise, it's an image from the James Webb Space Telescope. It found evidence of very dense gas with fast motions in the vicinity of the black holes, as well as hot and highly ionized gas illuminated by the energetic radiation, typically produced by these monsters that are feeding voraciously on the gas around them and accreting that material. So you're looking at something that was happening just 740 million years after the Big Bang. And of course, the question is, as I said, how did supermassive black holes acquire such an enormous mass that soon after the birth of the universe? And it demonstrates that we still don't know much about how this can happen. There are plenty of ideas, but there's no definitive theory and explanation yet. So that's that. Moving on, the Bepi-Colombo spacecraft is in trouble. Now, you may know about Bepi-Colombo. If you don't, it's a joint European and Japanese probe to explore the planet Mercury. In fact, it's two probes. And it launched in 2018 as a joint mission between ESA and the Japanese Aerospace Exploration Agency, or JAXA. Each of those agencies provided an orbiter to explore the surface and interior and magnetic field of Mercury. And there's some information there about each one. The problem is that the European-built transfer module, which is used to generate thrust, failed to deliver enough electrical power to the spacecraft's thrusters before a scheduled maneuver on April the 26th. They are working to find out exactly what the problem is. By sort of playing around with it, they've managed to get the spacecraft's thrust up to approximately 90% of its previous level, but the power level is still lower than it should be, and they cannot at the moment restore the full thrust. Well, this is bad news because in September, Bepi Colombo will perform a gravity assist at Mercury in order to slow the spacecraft down, because to catch Mercury up, of course, being close to the sun, or relatively close to the sun, you have to move the spacecraft at a tremendous speed, and it needs slowing down again. And this maneuver is scheduled to happen in September. And what mission managers are saying is that if they can maintain the power level at 90%, then they should be able to get it there on time for its planned gravity assist. But if the power level drops off again, then the spacecraft could be in real trouble, because it may not be able to slow down enough to go into orbit around Mercury. So this is a bit of a problem for the European Space Agency, and obviously Japan as well. We will, of course, keep you fully informed of any developments with that. So the reddest object in the solar system turns out to be a moon of Jupiter called Almathea, and NASA's Juno probe recently photographed it against the background of the red spot, and there it is. And this little moon of Jupiter is the reddest object in the solar system. It doesn't look red in these images, but it is. And it's not fully understood why it's so red, but it's thought that it's accreting material blown off by the volcanoes of Io that are being transferred onto Almathea. Almathea is about 52 miles across, and it's shaped like a potato. And in fact, you can see it a bit clearer here. This is not the same image blown up. This is an earlier image. Not sure which spacecraft took this. It could be Galileo, or it might even be Juno, although I don't think so somehow. However, lovely image of the reddest object in the solar system against the background of the big red spot on Jupiter. There's another strange fact about Almathea. It radiates more heat than it receives from the sun. And it is thought that interaction with Jupiter's magnetosphere is stirring up electrical currents close to the moon, which are heating it. But that's not been definitively demonstrated yet. So where do we go from there? Well, 3 of the universe's oldest stars have been discovered recently, and they are very close to home. In fact, 3 of the universe's oldest stars have been discovered in our Milky Way galaxy, which came as a real surprise. And they are on the outskirts of the Milky Way, if you like, in the galactic halo. They're 12 to 13 billion years old, meaning that they do date from the epoch of galaxy formation. And for these to pop up in the Milky Way, as I said, was a real surprise. It's believed each of the 3 stars was part of a tiny forming galaxy that was then subsumed and absorbed by the Milky Way. And these were originally observed by the Magellan telescope, but they've been laying in a catalogue, and a group of students at MIT were given the job of searching for stars with surpluses of strontium, if I remember rightly. And these 3 popped out of the catalogue. Nobody had actually analysed their spectra until then. And when the spectra were analysed, they turned out to be extremely old metal-poor stars. And the European galaxy mapper, Milky Way mapper Gaia, which is doing, as you may know, fantastic work and making many major discoveries, then discovered that these 3 stars are moving in a retrograde motion around the halo. In other words, the opposite direction to other stars in the halo, which made them stand out even more. And when they put all this data together, they realized that these are, in fact, 12 to 13 billion years old, and therefore some of the oldest stars ever seen in the universe, and they're in our very own local galaxy. So that's great news. And then, we've talked a lot about the aurora, obviously, recently. Just wanted to show you this NOAA image of the aurora encircling the northern hemisphere. And I think you'll agree that is quite an amazing image.
Lovely.
Isn't that fantastic?
Lovely.
And you can see the extent of it, and you can see why it was seen so far south. across the UK at the bottom there. Bizarrely, I've heard several people in Spain say that the aurora was visible from Spain. I've had several people say, "Oh, yes, it was visible from Spain," but I don't think it was. It's just too far south. We did see, obviously, the aurora a lot further south than we normally see it, thanks to the intensity of that geomagnetic storm originating from that monster sunspot. 8466, wasn't it, Daz, if I remember rightly?
No, it was but that aurora was from 3663.
3663, that's right. So this is why we saw it so far south, because of the sheer intensity. Incidentally, the disruption of Earth's magnetic field was actually measured at the bottom of the ocean. That's how strong it was. I was reading today. So are we going to get more geomagnetic storms as we approach solar maximum end of this year into next year? Well, I'm sure Daz is going to tell us what the forecast is a little later. And then finally, as I mentioned earlier, Starship has performed a wet dress rehearsal, ready for the fourth attempt to A, get the vehicle to orbit, and B, bring it back to Earth. And this is I just found this an amazingly beautiful image of that wet dress rehearsal. A wet dress rehearsal is where SpaceX go through all of the process right up until they would normally ignite the engines. So it's a test of the fuel system, all the plumbing, everything that happens before an actual launch. And it seems to have passed this test with flying colours, because they haven't done another one. And it looks as though the whole thing went ahead very smoothly. So we are getting quite close to that launch of the Starship, which is probably looking at it going to be around the first week of June, if everything goes to plan. So there we are. So that's the news for this week. And
Andy, may I say something about the auroral observations?
Certainly.
As I was mentioning, I was just attending a talk today by Stephen Voles, who's head of NOAA NESDIS, their Environmental Satellite Data Information System. They're the part of NOAA in the U.S. that launches satellites and deals with the data. He was mentioning how important it is to have spacecraft orbiting at the L1 point, a million miles toward the sun. We have 3 spacecraft there right now: ACE, Advanced Composition Explorer; SOHO, Solar Heliospheric Observatory; and DISCOVER, and I don't remember what that stands for. But these are very, very old spaceships, and they need to be replaced. So NOAA has developed and will launch in about a year what they're calling SWIFO, their Space Weather Follow-On mission.
Yeah.
And having missions orbiting in a kind of halo orbit around that point gives us about an hour once a CME hits that location to prepare. And so he made a point in his talk that there were very few disruptions of satellite operations because they had that hour to prepare.
Right. Yeah. I mean, you can't do much in an hour, obviously, but
make a cup of tea, perhaps.
Make a cup of tea. Yes, absolutely. I've got another image of the aurora. Just give me 1 second. I'm just going to put this up on the screen. Just give me 1 second. This is an aurora taken in. Oh, hang on, that's not what I wanted. I've got to. Sorry, I'll just switch this off again. Just give me 1 second. So I'm still trying to get used to this new software. The thing is that these were aurorae that we haven't seen, for 20 years or more, and it's surprising to me how varied this aurora was, depending on where people were. So if I can just get this up on the screen. Go away. All right, we've got a problem with this. I'll come back to this later. but I've got a lovely image that was taken in Wisconsin of the aurora. So there we are. All right. Well, let's move on. I think we'll go over to Daz now, because I'm sure Daz would love to tell us exactly what's going on with the sun at the moment. Would you not, Daz?
That's me, is it? It's me.
Yes.
Right. First of all, there are a couple of housekeeping things. Yeah, thanks, Kev. It was 3664. As I said, but what's one amongst friends?
Yeah.
Yes, because if I remember rightly, it was virtually 2 flares, literally one after the other. They were almost synchronized, if I remember right. So yeah, thanks for that, Kev. Right, let me just get me thing up. Here we go.
While you're doing that, thanks to Daryl, who typed in the DISCOVER stands for Deep Space Climate Observatory.
Oh, there we are then.
Very good, Daryl.
That's me.
Yeah. Right. Sorry.
Okay,
Before we go any further, I've got this up on the screen now. This is the aurora as seen from Wisconsin. Look at that.
Oh, lovely.
Isn't that beautiful?
Wow. That is a real weird shape as well, isn't it?
Isn't it?
Looks like an onion.
Yeah, it does.
A red onion. Yeah.
Yeah.
Been cut in half. That is
I
beautiful.
I just thought I'd show you that.
And the way it's sort of like framed with that farmstead in the
Yeah.
middle. Absolutely fantastic.
That was if you want to see that, viewers, that was NASA's astronomy picture of the day, I think 2 days ago. But absolutely beautiful.
Right. Okay then. Okay then, Andy. Yeah.
Yeah. Sure.
Okay. Right, here we go. Right, I've got to come up here, haven't I, so I can run the thing. Oh, it's disappeared. That's all I need. Oh no, I haven't. Here we are. Right. Okay. And then there's just can you see that?
Yeah.
It says I'm at 60 degrees. Now this was Kenneth last week, who's in Norway, and as I said, he was talking about the BZ values, and I said I wasn't really au fait, but the actual, because he said that he's had KP indexes as low as KP 2.33 with huge negative BZ values, and then on Saturday they had a KP of 7.33 but positive BZ levels and nothing visible. Now the thing is, the answer's in the question there, and it's this negative and the positive. Now I knew the BZ was to do with the direction of the magnetism actually within the geomagnetic storm, and what you need to have is this negative, because that's telling you that it's got a southward component. Remember when I said you've always got to have this southward a south magnetic component to be able to get aurora, and he's actually answered it himself. He had a positive BZ level on the Saturday, so that's why he saw no aurora that night, or if he did, it would have been very small and right up in the very top of the northern hemispheres, if there was anything at all, because that is a very high KP index. But the actual structure of the magnetic field within that storm was north, so you wouldn't actually get the aurora. So that answers that question. I hope that answers your question, Kenneth. I don't know if you're in today. Now we were also talking, I think it was Kev and Lee were talking about the flares that happened on the day that we were actually on the show last week, which was the 14th. And then Kev pointed out that there was an 8.8 flare from our old friend AR3664. Well, that was, of course, A3664 at the time was just going off the limb, and we couldn't actually see the surface of the sun. So we didn't actually get the full benefit of I've just noticed, I've just looked at YouTube, and all I can see is our pictures. Can you actually see what I'm putting up?
Not yet.
Oh.
Yeah.
No.
It's gone.
It's
No.
gone, is it? Let me just come back here and see what's going on. Live.
Do bear with us, viewers.
Yeah, I do apologise that because I'm talking away and I wasn't watching. Can you see that?
Yeah.
Bit
Right,
late tracking this down.
right. So let me just. Is it still there?
Yeah.
Yeah, that's okay. Sorry, I'll just pop back to because I did have Candace. As I said, the answer to his question was actually in his question itself, and it's this negative BZ and the positive BZ. Negative means the components in the geomagnetic storm was southward, which is what we need to get a nice aurora. If it's northward, which is positive, you won't see it. So that's why he didn't get to, although he had a very large KP index there, he didn't see anything. So that's why that happened. I do apologize for waffling on, and you can't see that. As I said, the second question was about this, well, not a question, but we were talking about this X 8.8 flare from AR 3664. Well, it was just going off the, as I said, off the western limb. So we couldn't actually see the base, see the actual sun's surface where it actually erupted from. And there is a question that basically they think that it was bigger than the Bastille Day flare from July 14th, 2000. And they think because we couldn't actually, it's the 17th largest flare ever recorded. I don't know whether that's since when, but they also think because we couldn't see the base of the flare from when it actually happened, we didn't get the full effect, and it could have been as high as an X18 flare.
God.
So what they actually saw, so what we saw was already high in the atmosphere of the sun, and it did throw off a thing, but they reckoned with an estimation, back engineering it, it could have possibly has been as high as an X18, which would have been absolutely astronomical if it came towards us. So that was what happened on the sorry, that's what happened on the 14th last week, what we were talking about. So I hope that just explains a bit more. As I said, AR 3664 was off the limb, and they reckon back engineering from what we actually saw, and how fast these things were traveling, that it was it could have been as high as an X18, but this was heading to Mars. So at some time, it was going to hit Mars, and it was going to possibly cause. I don't know if anyone's been able to see aurora, but I'll talk about that a little bit more in a little while. I think that's basically all the what I needed to do, what I needed to catch up on. Right, so space weather report. The sun calms down. Now we started, as we said, on the 14th. We had 13 active regions. The information's at the top if you want to read it. With a sunspot number of 207. And then currently today we have 6 active regions visible, although you can see more there. They're talking about the large ones that are actually doing anything. And we've got a sunspot count of 124. So we have dropped quite substantially in sunspot numbers and in active regions numbers. So you can see everything sort of like slowly calming down. And if I get me paperwork, it'll probably help me thing. We did see some X flares on the Wednesday. Oh, sorry. Here we have got 2 corona holes at this moment in time in our direction. As you can see on the right, it says hole 39. The solar wind will basically be going north of us, but it is a component that is actually pointing towards us. And if the wind's strong enough, it could actually create auroras in its own right, if it's strong enough. So we started the week. We got our usual timelines here. So Restart. There you go. We stopped it then. So here we are. This is a week in 100 seconds. And you can see we start off with quite some big flares. We had some big flares on the Wednesday and Thursday. And then since then, we've had just C flares and a few M flares. So everything is quietening down. We did have high hopes for what was coming from the eastern limb, because if you remember right, we could see these active regions just beyond the limb firing off all over the place, mass ejection, CMEs and flares. But once they've come round onto the sun's surface, they've sort of like fizzled a little bit, and they've sort of like been very, very quiet. So as you can see, we're still going on. There was a nice big flare there on the left-hand side. But as I said, they flattered to deceive at this precise moment in time. And what has happened since all these spots or active regions have come round, the sunspots. I don't know if you just saw that big ejection off the bottom. There will be a second one, sort of like at the 5 o'clock region a little bit later, associated with a small flare. But I'll show you that in more details in a little while. And you can see this coronal hole at the top here, where this darker region is, and there's another one just around the corner here. But yeah, we've got plenty of filament action going on. You can see this one running up through here. I'm not sure if it's connected to this region coming here, or just carrying on up. But yes, there are still some filament action going on there. So I'll just do it in a different way. Now, another apology for last week. I couldn't remember what we measure the the wavelengths in, and I know I mentioned probably nanoteslas. Well, that measures the KP. I was thinking, what I was trying to think of is angstroms. So the actual wavelength is measured in angstroms.
Daz, you're fired.
Oh, thank you very much. There we go. So we'll just try and start this one. Let's get it going. There we go. As you can see, we've got all these active regions. Again, this is from the 14th. They're Russian patch. You can see all this action going on here with the magnetic lines and the arches all happening. We've also got it on the western limb, as well as all these sunspots roll out of view. But as I said, we were very, very hopeful that all this around here, what we were seeing during the week, was actually going to, at the beginning of the week, was going to present us with some nice action that we could continue with the auroras and things like that. We did have throughout the week some minor storms. They were G1s and G2s. So if any aurora, and some of them were hitting us during the day for us in Europe. So if anything did happen, it happened at the very high latitude, so we didn't see them. So yes, the week is ending in bit of a sizzle rather than actually a bang. But hopefully there are things that are coming round, which I'll just talk about in a second, that will possibly kick all this off again. You can see there was action going on, but it's very small and very it wasn't the big flares, it's just small flares, and you can see what ejections there isn't much in the way of a big CMEs happening, which you'll see in the next rotation that I just put on. Of course, we'll go to the coronagraph next, and then you'll be able to see what's going on. Now, there are some glitches in this. I think they had some problems with the some of the imaging, but we will go to the next one, so you'll be able to see the coronagraph, see what ejections we did have in the during the week. And so here we go. Now we've gone back. That's silly. Yeah, I'm definitely sacked. So should start on a click. There we go. Now we started with, of course, we talked about those big expulsions at the beginning of the week. As I said, we had some X flares to begin with. Now, if you can keep an eye out, now let me just see if we'll find. There is, I think, about the 20 something or other. There you will see a complete halo erupt. And I'll tell you when it's all like coming up. It's a little way off, yeah. But you will see a complete 360. Remember, I was talking about the 360 halos that usually gives an indication that stuff is coming our way. Well, this 360, it was a bit deceiving because they decided to. It happened at the same time as a small C class, I think it's 6.7 class flare, and they thought that this was probably the a 360 corona from this. But using the other instruments that uh, uh, Lou was on about, looking at it from different angles and things like that, they actually discovered that the complete 360 halo was an event that had happened. There it goes. Just saw it there. Actually happened on the far side of the sun. So it was heading away from us. It disguised the actual flare that we was looking at. And that was basically that was just reabsorbed by the sun anyway. And you can see the planets all coming in as you saw with Roger's presentation. All the planets are around by the sun now at the moment. So I think that could be either Jupiter or Venus or something like that. So that's what's happening. As I said, that big flare that went off was heading towards Jupiter. So there's a lot to Mars. So if I can just go on and see what we got next. Come on, there we go. Right, now you can remember when we were running this is only a short one. Right, if you go away, because every time that does that. There we go. Now you'll see a massive filament liftoff here, which did give us quite a big CME, but as you can see, it's on the south of the sun, so it's all heading southwards. It was a very big. Well, just run that again because it was it's lovely to see. Now this actual flare was actually over 100 Earth widths across. It was absolutely huge. Which is, if I can just find my information quickly. So it was 100 Earth lengths across, so that's around 800,000 miles or 1.4 million kilometers long. That was.
That's insane.
So that is absolutely huge.
That's insane.
There it goes again. There. Absolutely gorgeous. And as you said, you could see that on the standard one, but you can see a lot of it actually fell back to the sun itself. But that always happens. So, but the next day there was something very similar, but this time on the southwest of the actual sun. So here we go. Let's start this. Get this going.
Southeast or southwest?
Southwest.
Oh.
So we got this flare. Now, if you watch this a little bit longer, you can see all this coming down through here. And again, that would cause another big, sort of like I say a big coronal mass ejection, but there isn't that much matter actually in these CMEs. And of course, they're not directed at us. We might get a little bit of a side swipe, but I think when they modeled it, there was nothing there worth to talk about. So let's just watch that again so you can see it. You'll see a flare, and then this all comes off, and you can see it all running down here. But there was actually a coronal mass ejection included in this, as we saw before. So that was on the 20th. Of course, we're on the 21st now, so that was yesterday. So just what we got next? Right, we were talking about our old friends AR3663 and AR6334, and I've just noticed that AR664. This is an image taken by Perseverance on Mars, and you can actually see.
Wow!
At the top there, at the top right, that is AR3663. That is, and at the bottom, you've got AR3664. So they can actually be seen from Mars. and you can see there's even another little one just there. So they've survived. Remember, this isn't the far side of the actual sun. This is looking at it from a different angle, so more from the side. When this was taken, does it got a date? The 15th. It was already around. It already come around. So our eastern limb will be about here. But of course, this is, as I said, been firing off, and they're all Mars directed. So that was there. And then today, I think it was today or yesterday, we've got another picture. Yesterday it was. And you've got, I'm assuming this is AR664 from its position. And this is just coming, it's just going to disappear off the limb. But it was still can be seen from Mars. And it has been firing CMEs towards Mars. So 663's already gone round. Doesn't mean it's come onto the Earth facing side yet. I think it's still got a few days before it actually comes round. So as you can say, these spots are so big they can be seen from Mars. I just thought I'd pop them. I thought it'd be interesting. Now, I was talking to you last week, and I forgot to show you the rest of it. Remember this, the Bartel music diagram?
Yeah.
And it's basically the KP history. And it goes back, I think this one, it basically goes back to 1932. You can trace it back. But if you go on to the Bartel site, there's lots and lots of information there, up-to-date stuff and historic. So as I remember, as I said, this is not the days of the month. It is days in the solar rotation interval. And as you see, there's only 27. Because it's almost 28 days that it takes for something to actually rotate completely around the Earth. Now, this was the big aurora just here. And you can see we did have some little glitches and things like that came on afterwards. But they didn't really amount to anything, which was sad. But I think this is the one that Kenneth was on about, and he said it had a north component, which means it didn't actually produce anything. I wouldn't have known because I know I was clouded out because I did go out to have a look at that. But you can see it's sort of like everything's died down, and it still is dying down. We've had nothing since sort of like the 17th, 18th. So here we are. And this is just ticking along nicely. Now, I'm going to show you a full year. This is last year, 2023. And as you can see, it was a pretty quiet year. We've got the odd storm. If we start at the top here. In February, we had a nice, virtually a whole day of storming. But this is only sort of like G1, G2. Here we've possibly got a G3. But here we've probably got a G4, which means you're getting unsettled. But they're far apart. And then what we've got afterwards is really sort of like probably just making the G1 mark. And then we got some towards the end, of course, because that's when we would have been starting the, as we think, possibly the peak. But there's, like I said, there's nothing... there's no sort of like extended period of time. Now, what I'm going to show you next, and this is why I love this Bartel, is I'm going to show you 1950. Oh. Now, if you look here, look at them. All these storms, all these up here, all these bigger ones as well.
Wow.
And this is 1950. Now, this is what you've got to be, if we're going to have any possible... I mean, these probably didn't affect us hardly at all. Just gave us radio blackouts and a bit of a hiss at the higher levels. But what you've got to be concerned about is when you get levels like this over an extended period of time, and this is when we could start having problems. And as Lou said, we need the early warning systems. And as he said, we only get about an hour, depending upon how fast these things are traveling. Notification of what's going on, and we have learned our lessons. Warnings do go out, and as I said, basically all the, say, like the power companies, they have to turn off all their safety devices so as not to cause a cascade by shutting down different transformers, forcing the power into other transformers, making them shut down, and you end up with a blackout. I know it sounds counterintuitive, but that's what the sort of thing they have to do. And then if you get an extended period, they can also ask the public to reduce their usage again. I'm looking at YouTube again, and I've got just the background. Are you seeing these, Bartel?
We did do. Hang on.
Notice.
Why do they keep?
Okay. Don't know what's happening there. Anyway, not to worry.
Let me just turn you back on, because it really does. You have to see these to actually.
Yeah.
Just go for some reason. No, it says I'm sure. Oh, that's it. You put it back on. Thanks, Andy.
Yeah. I don't know what there, but we lost.
I don't know why it keeps turning itself off.
No,
but,
I don't know.
Yeah.
Anyway.
So we're going to carry on. I'm going to show you 1951, even more. And it's when you get, like I say, when you start getting all these sort of like G2s, G3s, and then it's jumping up, but you're getting very small. You're not getting the big gaps for everything to recover. And this is when you've got to be concerned. But if you noticed, like I said, 50, 51, I'm going to show you 52. There's 52 again. Look at all this up the top here. Like I said, it's all extended. You're only getting small gaps in between. And of course, each of these columns is 3 hours. So you're not even getting a day before another one hits. And then just about a day, another one hits. Then another.
This was a solar maximum year, was it? Which was the year?
I'm not sure, but this is a period of time when we had a lot of activity.
Yeah.
And if you remember, radio telescopes were just coming into their own to study the outer solar system and into the deep space, and they were working quite happily. Then all of a sudden, in the 50s, they've become virtually useless. The information they were getting was garbled, and they couldn't understand why. And somebody said, well, hang about, let's turn it around and face it towards the sun. And then they realized that all these storms were actually interfering with all the radio telescopes. Sure. So what they did is, for the rest of, while this continued, is studied the sun. So it's like I said, this is a really new science, and it was only in the 70s when we got space telescopes that we were able to specifically look at the sun, that we were able to learn all these things and different things. And as you can see, in 53 it's starting to calm down, but this is why I like this. You can go back and you can, as you said, you can choose the year, because I didn't put me KP cycles up. I would have been probably one of these. It probably was a maximum, but yeah, this is why I like this thing. It's history, and you can look at it in lifetime.
So what we're looking at, there was a solar maximum year in when was it? 1958 was a solar maximum year, and the one before that was 1947. So it's between the two.
Oh, so this actually could be. Remember when we've said? So you say it was 47. This would have been on the ascending year. Yeah. And remember, we've said that they've started to know that some people have started to suggest that there's a correlation between the bigger storms happening in the ascension of a cycle, and also there was this link between even and odd numbers. Yeah. So really, we should be looking not at the 11-year cycle, but the 22-year cycle.
That's right. That's right.
So yeah, you can use this, and this is what people are using. They're looking at it and they're seeing if there's correlations to see if they can actually, form any links or anything like that. But it's a new science. It's not that. It's only about 50 years old. I mean, it was only 100 years ago. We still thought the Milky Way was, 100 and 100. Yeah, it wasn't it 100 years ago that we thought the Milky Way was the whole of everything. It was the universe. So, okay, then I'll leave it there. I'm sorry if I waffled, but I just thought that'd be some people might find that of interest.
Thank you very much, Daz. That's great. Yes, so it's a bit of an uneventful week after the great climax of last week, but who knows what the week ahead holds. So I'm sure Daz will keep us up to date.
Because there are a couple of sunspots that have come in. AR679 and AR3679, AR3685. They are showing signs of increased magnetic interaction going on within them. So we're expecting possibly some higher level C flares and possibly into the M flares.
Sure.
And but as I said, we have got 336 coming back round and 33664 coming back round. So
let's see what they get up to.
Yeah. All right. Well, offer a resource, please.
Sorry.
Offer a resource for people who are interested in taking their own data on solar storms. There is a NASA program called Radio Jove. I'm sure some of us are familiar with that. At radiojove.gsfc.nasa.gov, and you can build your own dipole radio antenna and take your own data in the area of around 20 megahertz or so, and you can sense solar storms as they're happening.
Wow.
So you build the kit yourself, you solder all the electronic components, and I think they do it at cost about, I forget, it's somewhere between $100 and $200 US.
That's not bad, is it?
Not bad, is it?
Anyhow, it's once again, it is Radio Jove, JOVE.gsfc.nasa.gov, and you can build your own radio receiver.
Ooh.
Fantastic. Thank you for that, Lou. That's a useful resource. We will put that link in the description of this video if you want to. And Lou, perhaps you could put that link in the chat if you'd be so kind.
Yeah, I could, although I'm not. I have access to private chat.
Oh.
Or I'm not on.
You still haven't got the. We never solved that you haven't got access to the chat window.
Oh,
well, he's got it to our chat window, but he hasn't got it to Facebook.
No.
YouTube, I mean, sorry.
Yeah.
Not on YouTube.
That's very odd.
But if there's soldering involved, I'll need a responsible adult with me.
Yeah, that's true. That's true.
Yeah.
Well, anyway, we'll put. I'll just nick this off.
Oh, Ian's just put it in.
Oh.
It's Radio Jove gsfc.nasa.gov /kits/
Right. Okay. So there we are. I've just put it in the chat as well.
Thank you, Ian.
Thank you, Ian. Thank you for that.
Yeah. Thanks, Ian. Right. So just before we go over to Michael for news from Saxaward, just got something I want to share with you. Just give me 1 second. And this is literally hot off the press, and this has been sent in by Mick Dunn in Ireland, and this is one he took with his phone of the Aurora.
Wow!
Which is so. Thank you for that, Mick.
Beautiful.
Over there near Dublin. Thank you very much. That's seriously impressive.
That really is
absolutely. Sick, obviously, that I didn't get to see.
I mean, if you saw that above you, you'd think something really weird was going on.
Yeah, well, there have been lots of conspiracy theories.
Yeah.
I've gone green again. I'm turning into the Hulk again. One theory I saw said that the Aurora was fake. It was generated as part of the HARP project, which is a US government project to control the weather or something like that. I don't know. So, the usual lunacy abounds whenever anything happens in the universe, as we know.
I mean, as I said about the Aurora, there was lots of false information going around, some of it just due to lack of education, some of it just being malicious. But like I say, when you then go back and look at the Bartel music diagram and go back and look through the history, you will see we've survived a lot bigger storms for a longer period of times, and we're still here to talk about it. So it just put things at rest. Yes, there are problems that we could get from the bigger storms, but it's not going to be the end of the earth long doom and gloom that everybody keeps on about. That's for the filmmakers. That's for Hollywood.
But just in case, you could always start making amends to anyone you've hurt in the past. Just recently.
Yeah.
In case.
Yeah, absolutely. Anyway, thank you, Mick. Hope you and Anne are okay. Hope to get over to see you soon in the fullness of time. And there we are. So, Michael, what's going on with Saxavor then?
Right, I'm just going to share my screen in a few. That one. This is a video of the first hot fire test of the first stage of the new rocket that's going to be launched from the Saxavor rocket launch site in the north of Shetland, which will be the UK's first vertical launch site for rockets from the UK. So, that's gone again. Okay.
There we
go. Let's start playing this video. There's no sound to this. This is just a flyover of the site itself.
And don't forget, viewers, this is a UK spaceport. I never thought I'd hear myself say those words a few years ago.
Yeah. The rocket itself is a German-made rocket from Rocket Factory Augsburg is the name of the company. And they've been chosen to launch their rocket as on the first flight from that site.
Wow.
Yeah.
Yeah, they fired 4 engines. They staggered the start of each of them. If you go and look at this on YouTube, you can use the sound. They actually count the engines in. They had a gap between each engine start, but then they ran them for 20 seconds afterwards. So it was an amazing start. It's another tick off nearer to the launch.
Yeah, it's the first time I've seen that launch tower with a rocket stage actually on it. We've seen that launch tower several times before, but no actual vehicle on there at all. So,
but it's also got a very basic flame trench as well.
Yeah.
Directing everything away. So
it has.
It just goes over the land, doesn't it? So yeah,
absolutely.
Just imagine if you're the guy who was responsible for nailing that thing down, so it didn't.
Yeah,
a lot of responsibility.
Yeah. Lots of tent ties, bang it in.
Yeah, absolutely. Yeah. Thank you, Michael, for that. That's great. Keep us posted on that.
Yeah,
I can see you're dying to tell us about Planet 9.
Oh, I do have a slide. Yes, we can talk about that.
Oh.
So there's been a lot of speculation that there's another planet in our solar system, and I don't mean Pluto. For those of you who still consider Pluto, I understand. This is a result of observations of the outer solar system, of the TNOs, the trans-Neptunian objects, small bodies outside the orbit of Neptune. And some of them seem to be glomping together, right? And the astronomers who've been looking into this can't find a reason for them to be clustering unless there is Pluto is a planet. Okay. I'll pay homage to Planet 10 perhaps then.
There's always one, isn't there?
Yeah, there's always one. Yeah.
Unless there is another body of something like 5 to 10 Earth masses. And this is done by computer modeling. Okay, and so they take a body of 5 to 10 Earth masses, and they stick it out in an elliptical orbit that has a aphelion, the furthest point from the sun, of about 600 AU, and they run their models. And it turns out that they're very good at reproducing the orbits of these TNOs that we see outside the orbit of Neptune. And so recently, there was some more corroborating evidence. A group at Caltech ran their models again on these objects and confirmed that, yeah, that would explain it, why these outer solar system objects are orbiting as they are. There are other possibilities. There could be a black hole out there. There could be gravitational waves in the galaxy, but nothing reproduces the observations as well as a Planet 9. So it hasn't been observed yet. But as a result, there are some constraints on where you might find it. And so we're looking for it.
Amazing.
Mm.
And if I remember correctly, the supposed Planet 9 is at its greatest distance from the sun so far that it would take about 2,000 Earth years to orbit the sun. That's how far away it goes, as you can see from this diagram.
All of our viewers know Kepler's third law: p squared equals a cubed. Right, the period squared equals the distance cubed. So they can work that out for us.
I think it came out to about 2,000 years. But, you know, there've been lots of proposed orbits for this. And, of course, the big problem is actually finding it, because finding a needle in a haystack just doesn't cut it, really, does it?
Yeah.
Ian says rocky or gaseous or icy, we don't know.
Almost certainly icy.
Yeah, it's got to be in those temperatures. Yeah.
So 5 to 10 Earth masses, if you look at what we know of the solar system, would make it a super Earth, not quite Uranus or Neptune size. So I imagine it's a large solid body. Now we haven't observed it, so we don't know if it has an atmosphere. Blah blah blah. But that's the guess.
Yeah.
And it is well within the Oort cloud. Oort cloud is out at something like 50,000 AU, something like that. So it's well within the Oort cloud in the Kuiper Belt region.
Yeah.
So where is Voyager 2 compared with Planet 9 is?
You guys are really making Voyager 1 and 2 are something like somewhere between 150 and 200 AU. I don't remember the number, but they're traveling outward at about 3 AU per year.
Right.
So they are inside the aphelion distance of this supposed planet.
Yeah. Amazing. Absolutely amazing.
Yeah.
Yeah. So, well, it's going to, you know, as we said, it's going to be very, very difficult to find that, because it will be at that distance, even though, you know, it's how many Earth masses did you say, Lou?
5 to 10.
5 to 10. It's still going to be very small, and you know, to spot at that distance.
So you have to count on it having a highly reflective, icy.
Yes.
And as long as there's government money out there to grants to be given, people will be looking for it.
Is this conceivably something that the Vera Rubin telescope could spot when it comes online?
I don't know. I think that would be within its purview of looking for very broad scale over lots of the sky at once, right? Looking for things that are changed, kind of like the large-scale synoptic telescope. I think so, but I don't know if that's in there.
That would be an interesting thing to find out.
Yeah, it'll take quite a lot of observation to be able to detect and measure its actual orbit, where it's going, to predict it. So yeah, it'd be, you wouldn't, you know, you'd have to look at it for quite a long time.
Well, I put this challenge out to all our C-Star users. Find that planet and report back.
Do we get to name it if we see it?
Suggest a name.
IAU
gets to name it.
Yeah, that's it. That's the trouble, isn't it? The international.
Well, we will see what the next few years holds for Planet Nine. But thank you for that, Lou. It's an ongoing,
getting back to poor old Pluto, it's still not done its one orbit yet since its discovery.
No, of course not. No, that's true. So that's true.
Mr. Tombe.
Yeah, absolutely. All right. Well, I think that's about it for this evening. Is it not? Well,
there's just one thing. We should have been. Well, we were hoping tonight to have a short break and then move on to watching the launch of the Starliner tonight. But of course, that's been moved to. Originally, it was moved to the 24th. The 25th. Sorry.
Yeah.
And that's even been now moved to the 26th, which is Sunday, I do believe. So hopefully we should be able to.
It might be on next week's show before the time's out.
Yeah, we might be able to cover it live next week.
Yeah, on our birthday.
Yeah.
Oh, happy birthday next week.
I just feel sorry for the poor astronauts having to go backwards and forwards. And I bet they ring up. In the morning and say, "Is it worth me coming into work today?" No, you're all right. Yeah. Come in tomorrow.
Are they both going to retire after this mission? Do you think?
Yeah.
Well, they might retire before it launches.
Well, given the white hair they're likely to have when they come back,
it is so frustrating. I mean, this is causing so much problems.
Yeah.
I don't know if we mentioned it last week, but. They've even ULA have now even got the US military on their back who are fining them now for delayed launches because they've got satellites that have been delayed and they're stacking them up, and they're very concerned now. They're actually fining them for delayed launches, but also they think that they haven't got the way of all to actually produce the rockets once it does get certified to produce them quick enough to get these satellites into orbits. And of course, we know the Russians are launching dodgy stuff at the moment, according to the latest, and the Chinese. So the Americans want to get their dodgy stuff up.
Can I just say as well?
Low Earth orbit is not for the faint of heart.
Yeah.
No.
How many ISS crews have trained to receive a crewed Starliner since its announcement as the crewed flight? So,
I don't know.
Yeah.
There was a problem a couple of years ago where they think they wouldn't have enough astronauts.
Oh, I think that's still ongoing. The astronaut shortage. I did write for them, but they didn't seem interested.
Yeah, if everything was running smoothly, they wouldn't have enough astronauts to actually man these things because the cadet force has been reduced.
Yeah,
and with all the planned flights, so in a way, it's worked out for them in that scenario. They need to need another astronaut. So they need a few more so they can get some more up in and trained up. So
this is a case of the chickens coming home to roost, because if you remember a couple of years ago, ULA were awarded launch contracts over SpaceX, and SpaceX took the US government to court because they said that the procurement process had not been followed correctly and that there was bias towards ULA, and SpaceX lost. And now we're seeing the result of not going with SpaceX but going with ULA instead, and it's all turning a bit bad, really.
Right.
Yeah. All right then. Well, let's wrap things up for today. Obviously, first of all, we'd like to say a big thank you to you, our viewers, for joining us on this Tuesday evening for Space Oddities Live. Thank you very much for your company. Thank you very much for your messages and everything else, and especially, obviously, those of you who have donated to us this evening. Those of you who continue to send us wonderful images, including that literally hot off the press image I received from Mick. So thank you, Mick. And we will be back, of course, at the same time next week. Not sure what we'll be doing yet, but we'll do our very best to keep you informed about everything that's going on in astronomy and spaceflight and everything else. So from us all at Space Oddities, you can say goodnight to the gentle viewers, guys.
Good night, everybody. Keep looking up. Keep looking up.
Oh, Lou, have you had that operated on? That looks painful. Oh God.
he's had the webbing removed.
Okay, so we'll be back next week with more Space Oddities stuff, and from all sorts of Space Oddities. Thank you for being here.
Yeah.
And
Thank you.
bye bye.